same denominator. Again, you can check the graphs, putting it in your graphing calculator, which I would do. So I'm going to factor the my equation again. This time I have x plus 3 all over x plus 3 times x minus 2. So to find my domain, I set the denominator equal to 0. So I've got x plus 3 times x minus 2 equal to 0, or rather it cannot equal 0, right? So I have x plus 3 cannot equal 0, and x minus 2 cannot equal 0, so I get x cannot equal negative 3, and x cannot equal 2. So my domain is going to be from negative infinity to negative 3, joined with negative 3 to 2, joined with 2 to infinity. Okay, great. Vertical asymptotes. So now I'm going to look at my equation. I'm going to bring it over here. So my equation says f of x equals x plus 3 all over x plus 3 times x minus 2. Well, I can cancel something out, right? I can cancel that out. So that makes my equation equal to 1 over x minus 2. So this time I do have a hole. I have a hole at x equals 3. So I have to find the y value for that, and we're going to do that in just a minute after I talk about the vertical asymptote. My vertical asymptote is my other one. What's going to make my denominator 0 now? Well, x equals 2. So I have one vertical asymptote and one hole here. How do I know where my hole is now? So I know the x coordinate of my hole is at 3. X equals 3. And now I need to find the y coordinate of that. Well, it's pretty easy. I'm going to take this value, I'm going to take my 3, and I'm going to plug it into my equation. And you can plug it into either equation, either the original one or the simplified one. I like plugging it into the simplified one just because there's less work. It's easier, right? I mean, honestly, it's a little easier to find. And I'm sorry, should be negative 3, not positive 3. So here we go. So I'm going to just find f of negative 3. So I have 1 over negative 3 minus 2, which equals 1 over negative 5. So I have a hole at negative 3, negative 1/5. Okay? And then we're going to go on to the next one, which is my oblique one. Okay? And I'm going to use my original equation. So I've got x plus 3, f of x equals x plus 3 over x squared plus x minus 6. And again, my degrees here. Okay, so degree of my numerator is 1, degree of my denominator is 2, and 1 is less than 2. So that means n is less than m. So this is also case 1. So my horizontal asymptote is y equals 0. Okay, so now we're going to find my y-intercept. My y-intercept, I'm going to find f of 0. And that means that I'm going to plug it in. And again, I can plug it into either equation. I can plug it into the original equation, or I can plug it into my simplified equation. It's going to give me the same answer. So I always like plugging it into my simplified equation because I don't have to simplify later. That's just that's how I like to do it. So I've got 1 over 0 minus 2, which equals 1 over negative 2. So my y-intercept should be at 0, negative 1/2. Okay, great. And now I'm going to find my x-intercept. Again, I can use either equation, and I'm going to use my simplified one. So I've got 1 over x minus 2 equals 0. Cross multiply, and I get 0 equals 1. So for my x-intercept, There are none. There's no x-intercepts because 0 cannot equal 1. Okay, good job, you guys. And now we are going to graph. We're going to graph all the little bits that we have and see if there's any extra points I need to find. Okay, so what do I know? Well, I know that I have a vertical asymptote at 2. So I have a vertical asymptote here. And I know I have a horizontal asymptote here. And I know I have a hole at -3, -1/5. So I have a hole, and technically it's just a hole. It's a hole. It's a hole. It's a circle. It's a hole in the graph. You guys know what holes in the graphs are. It's an open circle, okay? It means there's nothing there, okay? And then I have my y-intercept at 0, -1/2. Okay, 0, -1/2 is here. And then I have no x-intercepts. Okay, great. So I think I have all my points there. So now I'm going to find, how do I decide here where I want my points at? Well, I know that I want one from here over, from my hole over. And then I want one between my hole and 0, and one between 0 and my asymptote, and one here. So I want to find each one of those points. So luckily, I'm still going to just use the same numbers that I've been using, -4, -2, 1, and 3. Okay? So we're just going to plug it in, and again, you can plug it in either one of them, but I'm going to write the original equation down so you can put it into there. So it's x plus 3 all over x squared plus x plus 6. And if you're going to put it into the calculator or into a graphing calculator, make sure that the parentheses are around it. Okay, into Desmos, make sure the parentheses are around it. So here we go. I put it in there. My points are -0.17, -0.25, -1, and 1. So -4, -0.17, okay, -1, -1. Oh, 1, -1. Woo, helps if I read my things right? And 3, +1. Okay, so that means this graph, the graph on this side, is going to kind of look like this. Go to my hole, stop, pick up on the other side. So that's all a hole is. It's a hole in the line. It just stops in the middle of the line. So there's the hole. Okay, and the other one just looks like this with no holes. It just goes through the point. Now, most of your graphing calculators, I want to say, in fact, I haven't seen a graph calculator yet that will actually put the hole in the graph. So if you have a hole in your graph, and I have not found a graphing calculator that will actually put the hole in the graph for you. So you need to be aware of that fact. So I just wanted to throw that out at you. One more. This one should be fairly fast also. And then you guys are going to try this on your own.